Topic given for today's webinar is the structural audit and repair methodologies. I am Shekhar Gokhale from Mumbai. Firstly, I would like to thank HOD Civil Department and all coordinators of today's webinar of Ramdev Baba College of Engineering and Management for giving me this opportunity. I will start with today's topic. This is a very common phenomena during monsoon period every year in Mumbai, where there are a number of building collapses for last so many years. Recent ones are Bendi Bazaar collapse of 2018 and staircase collapse of Khar building in 2019. These are the two latest collapses in Mumbai. I'm coming to a very interesting slide. If we consider the asset value of the building versus the time or the service life of the building, normally when the work is completed, your asset value is 100%. The yellow line indicates the reduction in the asset value as per the accounting standard, that is a depreciated value. Say if you consider the service life of a building of 75 years, the asset value goes on reducing at 1.5 or 1.3 every year. If we consider 75 years, it is about 1.3% depreciation every year. So yellow line indicates that. But after certain years, like say about 15 years, the deterioration starts. And the problem of deterioration starts getting aggravated after about 30 years from the construction of the building. So if we consider the problem investigated and repaired at this point where the green arrow is shown, then there is a sudden drop in the asset value because of the building deterioration. So service life gets reduced because of the deterioration of the structure after say 30 years. So maybe after 15 years, certain buildings will start deteriorating rapidly. Certain buildings will start deteriorating after 30 years due to the environmental factors. So the yellow line shows the reduced service life, which should have been 75 years, it gets reduced. So by doing the structural audit and repairing the building at appropriate time, maybe after 30 years or 35 years, depending on the quality of work, we can extend the service life. The dotted green line shows the extended life of the building, and the yellow arrow indicates if the deterioration is more, if it is red line curve, then the difference in the green line and the red line, that indicates the increase in the asset value after repairs. So we can increase the asset value by repairing the building, but at a certain point of time, if the repair cost goes beyond certain amount, the viability of the repairs goes. Means if it is about 1,000 rupees per square feet is the cost of repairs, then it is workable after 30 years. But if the cost of repairs is going beyond that, then it is better to redevelop or reconstruct the building. So this graph indicates that. So at around near about 30-35 years, if you repair the building, you can extend the life of the building, as well as you can increase the depreciation value of the asset. Now let us come to the structural audit. What is structural audit? Structural audit is an overall health and performance checkup of a building, like a doctor examines a patient. Structural audit is an important tool to know the real status of the building and should highlight and investigate all the risk areas and critical areas. We can list out the purpose of structural audit as follows, like to save the life and property, to know the health of your building and to project the expected future life, highlight the critical areas that need to be attended with immediate effect, to proactively assist the residents and the society to understand the seriousness of the problem and the urgency required to attend the same, increase the value of asset by timely analyzing the condition of the building, and to comply with municipal or any other statutory requirements. These we can state it as a purpose of the audit. This basically gives a proactive assistance to the residents to understand the seriousness of the problem in advance, so that the building can be repaired before there is any problem with the building. There are certain statutory provisions made in the bylaws, like there is amendment made in the Maharashtra Municipal Corporation and Municipal Authorities Act 2008, dated to 7/2/2009, in which structural audit has been made mandatory. Then to check fitness of the buildings for human habitation is made in this provision. Examination by structural engineers is made in this provision, and it has been enforced with immediate effect. So all these municipal acts are amended. In Mumbai Municipal Corporation Act 1888, insertion of section 353B has been introduced. Similarly, the model bylaws of the cooperative societies are also amended. There is a clause 77 which says that the society shall cause the structural audit of the building in following cases. Up to 15 years from the completion of construction, no audit is required. Between 15 years to 30 years, audit is required to be carried out every 5 years. And beyond 30 years from the completion of construction, structural audit is required to be carried out after every 3 years. So a structural auditor is generally practicing structural engineer holding structural engineer's license of the municipal corporation, of the local state corporation, and structural audit shall give the fitness certificate to the building. And there is a provision of penalties also made if structural audit is not carried out. So these are the changes made recently in last 8 to 10 years in the bylaws and in all the statutory provisions. In Mumbai Municipal Corporation, they call it as a section 353B, which is inserted in the original MMC Act of 1888. Because of this change made in the bylaw, the municipal corporation is authorized to ask the societies or building owners. They are empowered to exercise their power under this act to ask the owners of the building to examine the building from the licensed structural engineer and submit the structural audit report within 30 days. Similar type of notices, the notice shown in this slide, are sent every year to number of buildings which are more than 30 years of age as per a municipal record. And they ask the societies or building owners of the building to carry out the structural audit within 30 days. Sometimes in this letter they mention the tests also, non-destructive tests also which are to be carried out. They specify the tests. And if the report is not submitted in 30 days, the reminders are also sent afterwards. So Mumbai Municipal Corporation is enforcing this quite in recent time, quite vigorously. They are enforcing this law, and they are asking all the society owners or building owners to get the thing done, structural audit done, and repair the building on time to avoid any accidental failure. Now, to carry out the structural audit, to what extent should assess the building? We have made 3 levels. Level 1 is a condition survey. Level 2 is a little more detailed survey, and level 3 is analysis, structural analysis and capacity checking of the structural members. Normally, we do level 1 and level 2 checks. Level 3 checks are not normally done. Level 3 checks are normally done for buildings where if you want to extend the building, like if you want to add number of floors on the existing building, old buildings. In that case, we go up to that level 3 stage wherein we need to analyze the structure again as per the latest and present codes, and then arrive at a conclusion whether the extension of the building is possible or not. Or in case of dilapidated buildings which are which are quite dilapidated or quite structure is quite distressed, then we need to carry out this level 3 checks. So normally in level 1 check, it is a condition survey where physical or visual condition survey of the building is made. Then drawings are studied, history of the construction is just understood, and rehabilitation, any work has been carried out earlier, that information is gathered from the owners of the building. This level of assessment is based on the experience. Based on the structural engineer's experience, he will visualize the things, he will understand the crack pattern and all that, and based on that, he makes the assessment. In olden days, prior to when the non-destructive testing was not readily available, most of the stability certificates were issued based on the level of experience of the structural engineer. So this is something of that category. And testing can be done with the help of a nylon hammer, where the hammer is tapped on the RCC surface and hollowness and delamination extent is understood. So this is a level 1 sort of a, we can call it as a condition survey. It cannot be considered as a structural audit. But if we level 1 and level 2 are done together, we can call it as a structural audit. In level 2, we do the verification of actual structural members, framing plan, sizing of the members, all we verify, found out. And then secondly, verification and inspection of some of the foundations we can do. And then detailed ND testing with reasonable sample size. Sample size is very important in this case. When we do any non-destructive testing, depending on the size of the buildings, you have to consider the number of samples to be taken. Because if a very large building of 1 lakh square feet or 2 lakh square feet is there, and if you are doing a very few tests, then your results may not give the correct picture of the building structure. So sample size is very important. So these are the 3: level 1, level 2, level 3 assessment levels. Methodology, how to go about. First is you have to find out the competent structural auditor to carry out the work. Generally, qualities of auditor should have sound knowledge of structural engineering, knowledge of material science and concrete technology, knowledge of construction practices followed in the past, then inquisitive mind, sound engineering judgment, knowledge to interpret NDT test results. These are the requirements of a structural auditor. Then what are the data required to be collected from the client? Basically, architectural drawings, floor-wise plans to mark the distress points. If typical floors are there, any one floor will do. If every floor plan is a different, then we need to get all the plans. Then floor elevation sections to get the dimensions and heights, etc. Then structural drawings, is that geotechnical report, foundation drawing, twin beam drawing, column schedule, floor-wise beam framing plan and schedule, terrace floor plans, etc. Normally what we observed, most of the building owners or cooperative societies only have the architecture drawings. Structural drawings are very rarely we could get the structural drawings when we actually start conducting the audit. So most of the times we have to rely mainly on architectural drawings. So normally what we do, we take the architectural drawing, prepare a actual framing plan on the architecture drawing with column numbering, beam numbering and all that, and take the dimensions of the columns and beams and mark all those things on the plan. And then that we use that plan for the actual survey of the building. And whatever differences we notice, we mark it on that. So normally structural drawings are not available. Architectural drawings only are available. So that is a major lacuna in the exercise, this exercise. Then normally we it's a 4-stage plan, we say. Stage 1 is a preliminary plan where we understand requirement of the client, collect basic information, Means what is the reason for going for structural audit? We understand whether it is required for BMC purpose, whether it is required to carry out the repairs, whether they want to do it for some bank loan purpose or something like that. So we understand the requirement, then collect basic information about the building, when it was constructed, how many times it was repaired, how many times it was painted, etc. Then identify and collect the useful documents and drawings. Then preliminary site visit to plan the survey and to record previous repairs. Identify any structural changes or alterations done. So in the preliminary visit, we try to understand what type of alterations, any alteration or change of user has been done, whether the building is designed for residential and it is being used for commercial or vice versa. We try to understand all those things in the preliminary stage. Then second stage is the planning stage, where we arrange for the tools, prepare drawings for distress point mapping. If the architectural drawings are only available, we prepare the structural framing plan first before going to actual site visit. Then arrange the team and plan survey schedule, etc. So that is stage 2. Stage 1 is preliminary, stage 2 is planning. Stage 3 is the detailed visual inspection. Detailed inspection of all areas of photographic evidence with photographic evidence is done. Study and understand the cracks, leakage points, deflection of floors, cantilevers, undulations in flooring, change in the loading pattern, etc. We observe and record. Discuss the occupants regarding their problems. Then record plumbing and waterproofing deficiency. Record observations on distress mapping and in various formats. And NDT testing at predefined points. These are the major, in stage 3, these are the major observations, the physical verification, then recording the observations and doing the NDT. That is the stage 3. Stage 4 is the compilation and conclusion. Compilation of data collected and understand the critical observations, marking all defects on their distress mapping, interpretation of NDT results, and final conclusion about the status of the structure. And the last 4 stages done at the office level again. Stage 3 is purely a site survey and on-site work. Stage 4 is the total office work. Tools required for the structural audit: generally good binocular, then magnifying glass to check the cracks, wire brush to open the cracks, Elcometer 143, that is crack width ruler, lightweight nylon head hammer, where we tap the RCC column, beams and slabs. Ringing sound indicates substrate is sound. Dull thud or pocal indicates a delamination or hollowness. By nylon hammer also, we can understand the overall condition of the building. Instead of going for, because a number of points and NDT points can be limited points. It cannot we cannot have number of points on each and every column or beam. So we just analyze the structure by lightweight hammer at number of points. Then whatever observations are there are marked on the distress mapping plan. Non-destructive testing instruments are required. Now, first part is the examination, second part is the evaluation, and third part is the prescription, wherein we suggest the remedial measures or structure strengthening, etc. measures. Importance of visual inspection. It is a very important step where experienced engineer is required to carry out this visual inspection. Preferably, structural engineer should go himself personally and take all the data or records of the visual inspection. To recognize the types of structural defects through crack pattern. Crack pattern gives a very insight into the status of the structure. Various crack pattern gives you the type of defect in the building. Then to identify any signs of material deterioration. Material deterioration or roughness or whatever environmental influence on the structural members we can visualize in this. Then identify any signs of structural distress, deformation, deflection due to overloading, any design deficiency or detailing deficiency. if a typical type of cracking pattern is observed in a particular building, from that we can make out if there's any design deficiencies there or a detailing deficiency is there. Then deformation and deflections also needs to be analyzed to identify any alterations or additions in the structure which may result in the overloading. So these things we need to, if there's an increase of the means floor on floor they are built, or they have made some false flooring, then some walls are constructed on the slabs, etc. All these are alterations, additions done after the construction of the structure, and those changes or those loading patterns are not considered in the at the time of design. So all these additional alterations we need to look into. Then to detect any dampness or leakage in the leakages from the terrace, toilets, plumbing lines, overhead tanks, drainage lines, which has an adverse impact on the structure. All these things, all these observations, physical observations of the visual inspection needs to be analyzed, recorded on the distress mapping or on the formats prepared for the inspection. Basically, this diagram represents a reinforcement bar. The left side top diagram is a reinforcement bar, cross section of the reinforcement bar, and on the adjacent is all concrete. So a reinforcement bar is properly embedded into the concrete. So initially, before the corrosion start, this is the condition. Then there is a buildup of corrosion in the reinforcement after some period of time. Then there is a crack formation on the both sides. Then further corrosion gives cracks on all the sides. This diameter slowly starts increasing, and the cracks will appear up to the surface. And in the next phase, even there will be a spalling of the concrete. This portion of the concrete gets debonded because of the further development of the crack. That is called a spalling of the concrete. So basically, a chemical reaction between cement and water in concrete, when the concrete is prepared, cement and water reacts to form a calcium hydroxide, and this ensures concrete's alkalinity. Concrete is generally alkaline in nature with a pH value of 11, and the alkalinity provides a protection to the reinforcement bars from corrosion. So if a concrete is dense and properly made with a proper mix and with a mix design and all that properly, then the pH value is around 11 or more. And as long as the reinforcement bar is within that concrete, dense concrete or properly compacted concrete, reinforcement will not have any corrosion. But because of the environmental influence and carbon dioxide in the atmosphere, there is reduction in the concrete's pH value. This pH value starts reducing from 11 to say 9.5 or so. This process is called a carbonation of concrete. So there is, because of the carbon dioxide and carbon monoxide in the atmosphere or due to vehicular pollution, there is a reduction in the concrete's pH value. This is called carbonation. Along with this carbonation of concrete, if there is a humidity and a leakage of water, corrosion of the reinforcement gets expedited. Basically, when the reinforcement inside the concrete corrodes, it expands 2 to 3 times to its original volume, causing concrete to crack. Basically, the cover concrete gets cracked first because the thickness of the cover concrete is less, and the phenomena takes over a period of time. This process may start say from day one itself, but it will get expedited after 15 years or 30 years, and then the disintegration of the structure starts. So basically, this is the major cause of our problem in the, because of in olden days we have used a nominal mix of M15 grade, where the durability aspect was never considered. It was only strength aspect was considered, and the code of 1962 or 1978 for IS 456 allows minimum grade of concrete as low as M15. So durability aspect was not considered that time, and this is the basic cause of all these structural defects due to corrosion. if the grade of concrete would have been higher in olden days, this problem could have come little later. So basically buildings uh, constructed between 1970 to 1980 and 1980 to 1985, they have got more problems because there was a shortage of cement that time, and M15 grade concrete was used. That time toss steel was used, which has got not uh, uh, the corrosion resistance of toss steel was not as good as present day steel, which we are using Fe 500 or Fe 550 grade. So all these factors are contributing to the this distressed condition or dilapidated condition of the buildings, which are constructed between 1970 to 1985. These buildings are generally in the range of between 30 to 45 years. These buildings are giving problems. And buildings, our experience suggests that buildings between 50 and 60 and 60 and 70 are comparatively better compared to buildings between 1970 to 1985 because of the cement problem. There was a shortage of cement during that period, and grade of concrete was M15. And in earlier days, concrete, that time also concrete grade was M15, but the workmanship at that time during that period of 1950 to 60 or 1960 to 70 was better compared to the structures constructed between 70 and 85. So we observe practically we observe the buildings between 50 to 70 are better compared to buildings between 70 and 85. After 85 again, the grade of concrete start improving and the quality of concrete also has improved afterwards. Now the types of non-destructive tests we normally carry out. There are a number of non-destructive tests, but these are 7 tests which are commonly used. One is rebound hammer test, which is called Schmidt rebound hammer test. Second is ultrasonic pulse velocity test, carbonation depth test, half cell potentiometer test, reinforcement locator test, moisture meter test, and concrete core test. I'll come one by one to all these tests. This is a rebound hammer test where this test has to be conducted on the bare concrete surface, means plaster has to be removed before the test is conducted, and the surface is scraped and cleaned before the test. This particular instrument is held perpendicular to the surface and pressed against the surface, and rebound hammer is pressed against the concrete surface, and spring control mass rebounds, and the extent of rebound gives us the surface hardness of the concrete. Hammer reading is locked when we press the plunger to the surface, and the Schmidt rebound value is recorded on the scale on the instrument. This rebound value gives the estimated value of compressive strength based on the graph provided by the manufacturer. Second test is ultrasonic pulse velocity test, wherein there are 2 probes. We can see in the diagram, there is a concrete block. On both the sides, there are 2 probes. One probe is used to transmit the velocity, and the other is for receiving the velocity. The time of travel of an ultrasonic pulse through a given part length of the concrete is measured. Now, from this, if it is this probe is transmitting the velocity, and this is the receiving velocity, this is the path. The thickness of this block is the path length, and the travel time is measured in the display, and the path length divided by travel time gives us the UPV. The UPV depends on the quality of concrete and affected by all its ingredients. Any discontinuity in cross section, like or cover concrete is delaminated, etc., then we get a lower UPV value. Then this method can be used in 3 ways. The photograph shown is a direct method where both the probes are on the opposite side of the member. There could be a semi-direct method when if the 2 sides of the member are exposed, like a column, the width of the column 230 side is exposed and other length side is exposed. Then the probes are applied on 230 side and on the length side. That is called a semi-direct method. And if only one surface of the concrete member is approachable, then we have to use both the probes on the only on one side, and that is called indirect method. But the direct method gives a better reading, and indirect method gives there could be a variation of about 5 to 20% in indirect method. So while taking the readings, as far as possible, we should take a direct method where probes are on the opposite side of the member. This gives basically a homogeneity and integrity of the concrete. It doesn't give the grade of concrete, it gives the quality of concrete, whether it is excellent, good, doubtful, or poor, like that. Then carbonation depth test. Carbonation I have already explained, where there is a reduction in the pH value of the concrete. Holes are drilled in the concrete, and phenolphthalein solution is spread in that hole, and there is a color change. Based on the color change, we can make out how much, up to what depth the carbonation has gone inside. So if the cover concrete of the column is say 40 mm, and if the carbonation depth as per this change in the color is say 25 mm, that means the carbonation has depth to the has reached to a depth of 25 mm, but has not reached up to the reinforcement level, since the cover is 40 mm. So there is some more time to expedite the reinforcement corrosion. So that we can make out from the carbonation depth test. Fourth test is a half cell potentiometer test. This is an instrument which measures the potential and the electrical resistance between the reinforcement and the surface to evaluate the corrosion activity. Here the wire is connected to one terminal of voltmeter and to the reinforcement, and another wire to the copper sulfate reference electrode. Potential drop is measured, which indirectly reveals the resistance offered by the concrete. Higher the resistance offered by the concrete to the flow of current, lesser is the possibility of active corrosion process. So based on that, we can predict the probability of corrosion. It will not give the extent of corrosion, it will give what is the probability of corrosion. Then reinforcement locator test. This is called a profometer, wherein we can move the probe on the surface of the column or a beam and identify the reinforcement bar, location of reinforcement bar. It gives location of the bar as well as approximate diameter of the bar. Then it can, from this using this instrument, we can, if we have the structural drawings available with us, we can just cross check whether the whatever bar shown on the drawing are whether provided or not in the actual construction. So we can have a cross check using this method. If there are 8 number of 16 mm TMT bars used or toss steel bars used, whether there are 8 bars or not, or the diameter of the bar is 16 mm or it is substantially different, that we can identify from this. So it's a useful tool to cross check whether the actual construction is done as per the structural drawings or not. Then this gives a concrete cover also. What is the concrete cover provided for the particular member? And this test is also useful before the core test is conducted, because to draw or extract the core from the member, we need to locate the reinforcement bars inside the member, so that while extracting the core, the reinforcement bar is not damaged. So this is useful for that also. And only limitation is the depth of rebars from concrete surface should not be less than 70 mm depth, and spacing of bars should be more than 150 mm. Then only this test is useful. This test can be conducted. Then moisture meter. Moisture meter is a small and reliable measuring instrument for the determination of existing moisture in the concrete and wood. This can be used for wood also. It offers preset characteristic curves based on alternative material densities. And digital moisture devices gives quickly and accurately the moisture measurement without causing the damage to the test material. Measure the moisture content in the surface. There is a core test, wherein a reinforcement is first located using the profometer to avoid of bars. Then cores are usually extracted by drilling using a diamond tip core cutter cooled with water. There's a diamond cutter, and a cylindrical core is extracted from the any concrete member where we want to test it. And this core normally is of 75 in diameter, and because more than 75 in diameter may not be possible because of the crowding of the bars in the in the RCC member. Normally 75 dia core is taken, and the core is actually tested in the lab for compressive strength. And the concrete, after crushing the core, the other chemical tests such as pH value, chlorine content, sulfate content, etc., can be done in the lab. So this is a confirmatory test, like a cube test. This actually gives the actual compressive strength of the member which was constructed some time back. So the rebound hammer test and ultrasonic pulse velocity test can give erroneous results sometimes, but this is a more accurate test, and we can rely on this test. And normally we suggest we should take minimum 3 samples. Even if a very small building is there, we should take 3-4 samples so that we can average out the equivalent cube strength. If the extent of the building is more, then we can have definitely more core tests. So core test gives a fairly good idea about the concrete strength of the building. Some time back, we have just compared, we have done 3 different buildings of different age group. Say Andheri Shilpa building was constructed in 1977-78, Shweta building was constructed in 1981-82, and Aditya building was constructed 2004-2005. All 3 RCC frame structure, more or less all 3 buildings were ground plus 7-story structures, and we carried out all 4 tests: ultrasonic, rebound, half cell, and carbonation, and we compared the results. So 1977 building gave ultrasonic results below 3, Shweta gave 3 to 3.5, and Aditya gives 4.2 to 4.8. Normally for UPV above 4.5 kilometer per second is an excellent quality concrete. So in case of Aditya building 2004-5, which is compared to new building, we got the best results. And this 1977-78 building, we got result lower than 3, which is a poor quality concrete. And we did rebound hammer also. We got a range of between 10 Newton to 18 Newton per mm square. For 81-82 building 16 to 20, and Aditya building 22 to 27 Newton per mm square. Whereas as per the present code, it should be more than 20 Newtons per millimeter square. Earlier it was 15. Then half cell potentiometer, we got -244 to -281, -1122 to -217, and -82 to -115. And carbonation indicating that Aditya is a lack of corrosion, Shweta is about 50% probability of corrosion, and Aditya Andheri Shilpa about 90% probability of corrosion. And carbonation depth also, there was variation noticed in that Andheri we got 10 to 60 mm depth. In Shweta probably the depth of carbonation is very high, 40 to 45 mm. That indicates the speed of corrosion will be high in this building in future. And Aditya carbonation depth was between 10 to 20 mm. So we just checked 3 different buildings and just compared the results, and they are more or less in line with the age of the building and their maintenance. The limitations of these tests. Basically, NDT tests are for a particular location. At a particular location, it will give the reading, it will give the strength, it will give the probability of corrosion and all that. And based on that, we have to extrapolate our results for the entire building. So firstly, we should have sufficient sample size. That is first thing, and we have to look from proper perspective, from visual inspection as well as NDT. We have to take all things together and then extrapolate results to the entire building. Sometimes we get good results in rebound hammer, but bad results in ultrasonic pulse velocity. So if there's a quite a big variation in both the results, then we normally go for the cohort test, and from based on the cohort test, we decide the fate of the building. Then readings are to be taken on a smooth bare concrete surface. It should not be taken on a plaster surface. If plaster surface readings are taken for rebound hammer or ultrasonic pulse velocity, then we are likely to get erroneous results. Then even the if the concrete surface is cracked, on that surface you take the readings will be erroneous. So you should not take the reading directly on the cracked surface. It should be adjacent to the cracked surface. Then large aggregate or reinforcement is there near the surface of the point of test, then we are likely to get a higher results. So that is also, so sometimes what we do, we take 2-3 different readings in the nearby area and then average it out to get us value for that particular test location. Half cell tests on epoxy coated steel does not give accurate results. And if a calibration of the instrument is also not done, that may give erroneous results. So all those things, all these limitations are there in the NDT testing. Sample size I already explained. It has to be sample size has to be consistent with the quantum of the building you are analyzing. So accordingly, you have to select the number of samples, test samples. Now we go to the case study. I have taken a very small ground plus 2-story building, which was constructed in 1970s for this today's webinar. It is in Vileparle East in Mumbai, and this is the building. This is called Vitthal Building, Vitthal Society. It is a ground plus 2-story structure. Year of construction 1972, approximately 48 years old. External appearance doesn't look very bad. It looks to be okay. But only thing, the plastic sheet provided on the terrace indicates there is some problem in the building. No major repairs carried out in recent past. Last repairs were carried out in 1999, and after that nothing has been done. BMC has sent a notice under section 353 for carrying out structural audit to assess the structure stability. So the reason or objective was to do the structural audit for the BMC purpose and also for carrying out the repairs, if at all they are there. So as per what I explained, we have got 4 stages. First stage objective was to carry for municipal submission and to carry out repairs. No major repairs carried out. Only architecture plans were available. Structural drawings were not available. A basic structural framing plan was prepared based on the architecture drawing. Columns, beams located on the plan with their sizes. External photographs were taken, but no other details available. So preliminary stage 1 is over. Stage 2, decide to carry out rebound points 20, ultrasonic pulse velocity 10 numbers, carbonation 5, half cell 5, and concrete core 3 points. Drawings prepared for the distress point marking. Then team of 2 engineers was planned for condition survey of the building and team of 3 technicians for NDT testing. Notice certain residential flats at ground floor were converted to offices, and in some few flats kitchen was converted to bedroom and balcony converted to kitchen. That these were the additions or alterations done in the building. We notice in the stage 2 inspection. Stage 3 inspection, the detailed visual inspection. We created a photographic evidence of the detailed visual inspection. These are the 4 photographs from that particular building where we observed vertical column crack due to the corrosion, and then some spalling of concrete we observed in the slab. Lintel beam also bottom crack we observed, which is due to also corrosion. Then the beam bottom crack was also noticed here and here. Then a major distress or notice in the column due to corrosion again. All these cracks are mainly corrosion cracks. Then we observed a plumbing problem, leakage problem, terrace leakage problem, and soffits of the loft slabs over the toilet blocks. Then we further notice in some of the flats there is unevenness in the flooring. The flooring line along the wall across the short span direction was at a higher level, and the central portion of the tiling was slightly lower. There is a gap developed along the tile joint, so indicating corrosion in the negative reinforcement. Then we prepared the distress mapping plan, which was earlier prepared. On that, we marked all this ground floor, first floor, and second floor. All the whatever distress points, whatever observations were there are marked with a legend, like column crack, we say CC, column cracks in the beam, we call it as a BC, crack in the slab, we say at SC, like that. Steel exposed, SE, external leakage, EL, like that. With some legend, we can mark all the defects and distress points on the plan at appropriate floor level, and these are quite useful in analyzing the structure afterwards. So this is called a distress mapping, which is a part and parcel of the structural audit report. Then we prepared some internal inspection reports, wherein flat number or room number is written, then room name is there, living room, kitchen, bedroom, etc. Structural distress in column, beam, and slab. If we notice, we mark it there. Leakage, dampness, external wall, ceiling, or internal walls, we mark it there. If at all there is a deflection in the flooring or undulation in the flooring observed, we mark it over there. And there is a remarks column to write the things which cannot be accommodated in these columns. So this type of charts we prepare. We prepare similar charts for external walls also, where instead of room number, we say a wall number, wherein each wall of the external face of the building is marked with A, B, C, D, E, etc. And the number of floor, like A wall ground floor is called AG, A wall first floor is called A1, A2, A3, like that. So with a wall marking and with a floor level, we identify all the distress points, leakage points on that chart, which is also a part of the structural audit report. There are a number of types of cracks. This lists out types of cracks. There are about 16 types of cracks. There are certain cracks before hardening of concrete and after hardening of concrete. We are at the stage of structural audit, we are only concerned with after hardening cracks. Those could be volume instability, structural or design cracks, or physio-chemical cracks. So in this, we have mainly design load and overload cracks. We have to analyze design and subgrade cracks, then steel corrosion cracks. These are the three main cracks we have to analyze during the structural audit. Similarly, cracks can be identified as, after hardening, we can consider it as a physical crack, chemical crack, thermal crack, or a structural crack. So for our purpose, it is the chemical cracks and structural cracks are important. This is the type of cracks we observed while inspecting the building. If it is a simply supported beam, we get a diagonal crack at a 45-degree near the support. These are shear cracks. This is because if there is a corrosion in the shear reinforcement, then such type of cracks are developed. Or if there is a deficiency in the shear reinforcement, then such cracks will appear. Then second type is a crack along the length of the building near the bottom soffit. These cracks are due to the corrosion of reinforcement, or if the concrete cover is insufficient, then this crack develops. Then if this is a plan, if there are number of cracks on the bottom of the beam, these are also corrosion cracks. If there are number of bars inside the beam, then there will be number of cracks. Then cracks due to the bending stress at the center of the span. there will be cracks developed. That is due to the bending of the beam because of the overloading or something like that. Then cracks due to compression failure in the beams. If there is any impact load or if there is a failure of concrete, then such type of cracks develop. In columns also there are diagonal cracks, horizontal cracks and corrosion cracks. Mainly we encounter in corrosion type of cracks. Like here, it is explained that the reinforcement bar, the diameter of the bar goes on increasing, and then the spalling of concrete takes place. This is a splitting crack because of the overload on the column. The cracks are developed. There is a bending of the reinforcement also noticed in this, and due to overloading on the column. And these are again the flexural and shear cracks in the beam because of the loading. Now we encounter this type of cracks in the structural audit report generally, which are the corrosion cracks, which are vertical near the corner of the column. And in this case, there is a very wide portion of concrete. This portion is likely to, the corner of the column is likely to fall shortly. Even the crack is developed in the tiled surface also in the kitchen. The crack is going vertically and near the corner of the column. Now coming back to our audit of Whittle Society, we have taken the 20 points of rebound hammer, and average 2 or 3 readings are taken for 1 point, and all the columns we are distributed ground floor, first floor and second floor. A few beams also we tested, and out of 20, all 20 readings, we got the average cube strength of 24.5 MPa, Newton per mm square. So these are excellent results considering the building is already 8 years old. So these readings we got on the rebound hammer. Then we carried out 10 points of UPV test. These are again, out of those 18 columns, we have taken few columns and 1 beam. Here we observed the difference. Most of the readings are doubtful and poor. So if we summarize the result, the velocity between 3 to 3.75, 2 readings are in this range, where the average UPV is 3.27, and below 3 there are 8 readings giving average UPV of 2.43 km per second. So all the readings are of either doubtful quality or a poor quality. So these two tests are giving a contradictory results. Your rebound hammer test is giving very good results, and this test is giving poor or doubtful results. So this indicates there is a concrete, there are cracks are there. UPV test results are low if there are inside the concrete there are micro cracks are there, or homogeneity of concrete is not good. If the concrete is not properly densed or compacted, then the UPV results are low, indicating it is a doubtful or poor quality concrete. So even though rebound hammer is giving good results, ultrasonic pulse width test is giving very unsatisfactory results. Then we further carried out the carbonation depth test. The general cover of the column was around 40 to 45 mm observed at site, and actual depth of carbonation is about 20 mm in all the 5 cases where we tested the only columns. Then half cell potentiometer test, again we tested the 5 columns. Out of 5 we got all 5 readings between -200 millivolt to -350 millivolt range. That indicates probability of active corrosion about 50%. So even though the carbonation depth is only 20 mm, there is a possibility of 50% possibility of active corrosion in the reinforcement. So to conclude, we carried out concrete core test at 3 samples, and column number 6, 9 and 12 at ground floor, first floor and first floor. We took the results, and equivalent cube strength given is 16.2, 13.38 and 15.02, which is averaging to around 14.87 Newton per millimeter square. So this is more or less equal to the design concrete strength designer must have considered at the time of the construction of the building, because in 1972 for a ground plus 2-story structure, designer used to take M15 grade of concrete only, nominal mixed concrete. So this is more or less equal. With some standard deviation we can apply, and we can consider the concrete strength is reasonable. The pH value observed was around 9.8 of the crushed core. After crushing, we took the pH value of that crushed sample, and average pH value of 3 samples is 9.8, chlorides is 0.33, and sulfates is 45. So as far as pH value is concerned, it has reduced from 11 to 9.8, indicating carbonation of concrete. Chloride contents and sulfate contents are within the limits. Chloride should be below 0.6 and sulfate should be less than 400 milligram per liter. So chlorides and sulfates, there is no issue. pH value in reduction indicates carbonation of concrete, and cube strength, this is, we can say it as a confirmatory test, is around near about 15 M15. So contents of the structural audit report. Now we go to the fourth stage of the structural audit, wherein we compile the data and all, prepare the structural audit report. So we should have a covering letter, then preamble, that means who has appointed whom, purpose of appointment, details of the, that is address, number of floors, flats, type of roof, RCC, staircase or tank, lifts, etc. details. Then type of structure, whether it's RCC, steel, composite, load bearing, whatever. History of the building, date of construction, structural alterations, past surveys and repairs. All those things we need to record and write in the report. Date of inspection is also required to be mentioned. Validity of the report also should be mentioned. Like your validity of the structural report could be for next 6 months. You have to mention that specifically. Structural audit observations, wherein cracks, leakage, deflection, settlement, plumbing and waterproofing defects you need to mention. Room-wide internal inspection report you can include in this. Photographs indicating distress areas are required to be indicated in the part of the report. Distress mapping sheet should be included in the report. Entity test results will be a part of the report. Then repair methodology, suggestions and conclusions are to be given in the report. Estimated cost of the repairs also can be worked out and given in the report if the client is asking for it. And summary of the structural audit report is to be mentioned. In Mumbai Corporation, Mumbai Municipal Corporation, they have given a pro forma B to the structural engineers. There is a standard format given wherein all this information which is mentioned above can be given in a summarized fashion. So I'm displaying the pro forma B. Of the building, year construction, age of the building. This particular pro forma is given with a date of inspection, date of preparation of report, etc. Foundations and beams and columns are which type. Then when the last structural repairs were carried out, any additions, alterations are there. External plaster, whether it's cracked, internal plaster, whether it's cracks. About plumbing, information is asked for. All these rows we have to fill in. They are specifically asked whether doors and windows does not close. This, if there is any settlement of the lintel beams, then settlement of uneven floorings, gap between the skirting and the flooring also need to be mentioned. Deflection, sagging of the slabs is observed, needs to be mentioned. All these details you need to fill. You have to summarize your non-destructive test results also in this. Then conclusions of the consultant are to be written. They have got different questionnaires. We have to go on answering the questions. And finally, classification of the buildings they are asking. category. They have made 4 different categories. They have called in Mumbai Municipal Corporation, they call it a C1. Hello.
Hello.
Hello, I am audible.
Yes, sir, you are audible. You can
Yeah.
continue for the presentation.
Okay. So these are the 4 different categories where we have to certify the structure or give the stability of the structure in these 4 categories. So before going to this actually pro forma B, the critical observations for uh, this particular Vittal building, the concrete is about M15 and not as present minimum required strength of M20. Reinforcement used is FE 415 grade. Beams are designed as a simply supported and framing action is not considered. Ductile detailing is not provided. Few additions and alterations carried out in the building, kitchens converted to bedroom and balcony converted to kitchen, but no deflection of balcony cantilever noticed. Cracks in the RCC members are basically due to corrosion, steel exposed in quite a few columns. Uneven flooring, tiles and gap between flooring and skirting notice indicating sagging tendency in the slab. RCC chajjas over windows are badly cracked and delaminated. Some of the column cracks are severe and needs to be repaired immediately. Soffit of some of the slabs is substantially cracked and delaminated, and loose portion needs to be removed immediately to avoid accidental fall. Leakage from external walls indicating delaminated external plaster. Terrace waterproofing is bad and needs to be replaced to avoid seepage of water in terrace slab. Plumbing pipes need replacement. These are the critical observation and findings from the this particular structural audit inspection. So our conclusion is structure is in an advanced stage of distress, and if it is not repaired urgently, it will have serious structural stability issues. So building is repairable, but it needs to be repaired efficiently. This is the conclusion of the report. So this particular thing, we have given a category C2A, wherein uh, there is a partial evacuation or partial demolition may be required, and major structural repairs are required in the building. This is the conclusion of the structural audit of this Whitnall building. So we understood how to carry out the structural audit. What are the levels of the structural audit? In this case, since it is there is no extension of the building, they are basically planning to go for redevelopment after a few years. So there is no vertical expansion of the building required. So level 3 type of audit is not required. Only first and second level audit we carried out in this case. In most of the cases, this is the way the structural audit